Hello and welcome to the latest webinar in the Elemental Talks program. Our topic today, CP1 Code of Practice for Heat Networks. Are you ready to meet the new standards in our session sponsored by Kingspan? The chair for the next 60 minutes, my name's Jim McClellan, founder and editor, SustMeme, home to both the magazine and the top 500 rankings. Joining me on the panel this afternoon are Chris Ridge, Technical Policy Manager, TICA, that's the Thermal Insulation Contractors Association, Michael Ridge, Principal Engineer, Fairheat, Mohammed Sharif, Design Manager, Eon Community Energy, and Stephen Glyde, Product Manager, Kingspan Technical Insulation. It is all live, as you will see, with Q&A to finish. So pop your questions in the appropriately named box you should see at the bottom of your screen, the Ask a Question box. If you type them in there, you pose them, I'll ask them, they'll answer them. So a little bit about Elemental. This webinar forms part of a program of talks hosted and produced by Elemental, elementalexpo.com. It's the online community for professionals focused on innovation in heat, water, air, and energy, as the name implies, the vital elements within the built environment now and in the future. You can find the full diary of events on the website, range of upcoming webinars. Also, you can now view the back catalogue, whole host of hot topics. They're all available on demand. Who's who of great speakers, and I should add, everything is free to access. Plus, next year, the physical, real-world, in-person Elemental Expo will take place at the NEC Birmingham, 21st to 23rd June 2022. So, see you in the room there. Right, very brief intro from me because we've got a lot to cover today. So, thermal insulation, carbon reduction, and net zero. We all know with the UK government having made an ambitious commitment to achieving net zero emissions by 2050, it is all hands on deck. Striving towards this goal, we've seen an increased focus on carbon, energy loss reduction in the construction industry, plus growth in the design and implementation of zero carbon projects. This drive towards cutting carbon also has direct implications for the thermal insulation industry, particularly with developments in building services specifications and standards, and a push to ensure that new and additional criteria are met. So, this practically oriented session, our expert panel explore the role thermal insulation can play, both now and in the future, in the drive towards cutting carbon and hitting those net zero targets. We focus on the CIBSE CP1 Code of Practice for Heat Networks, as everybody knows, probably recently updated in 2015, original 2020 version, what has been described as a huge step forward for the industry. More than 50 experts came together to agree the new code, 3 major rounds of consultations, one was public, involving around 100 or more contributors and generating 3,000 comments. Big piece of work. So what does it all mean? Well, let the debate begin. So as we start to explore the CP1 Code of Practice and how we make ready to meet those new standards, I'd like to begin by asking our panel to introduce themselves, share some opening insights around the code, insulation and carbon. So to kick us off, Stephen, in a nutshell, what is the CIBSE CP1 Code of Practice for Heat Networks and what is it trying to achieve?
So my name's Stephen, product manager from Kingspan, looking after pipe and duct insulation products, working on a lot of projects and specifications within sort of Southeast London area, and a lot of those are district heating projects. So CP1, the Code of Practice, so it's a standard, not guidance. Essentially, it's here to improve the quality of district heating projects. And that's essentially from the early concept stages right the way through to the final operation of the network. So the current version 2020 is an update of the previous one, which was released in 2015. And it represents quite a great expansion on that previous document with a large number of changes, including thermal insulation, which of course affects our products on the secondary network. But also, we believe that the UK Department for Business, Energy, Industrial have intended to legislate the document as well in the coming years. And also, CP1 has sort of fully integrated checklists now, so it presents a more structured and robust toolkit to check compliance for projects with the Code of Practice.
Excellent, thank you. And nice point there that standard, not guidance, robust toolkit. If I could just ask you a little follow on then. to be blunt, will it make deciding whether an insulation system is going to be sufficient for a project any less complicated? And if so, how will it help? Will it make people's jobs easier?
I think there's two sides to the coin. I think in some respects it's a little bit more complicated. And from that, I mean, for consultants and contractors, they're probably more used to general installation specifications, which usually just refer to minimum standards of BS 5422, rather than obviously within CP1, there is like a table 8, which lists the minimum installation thicknesses, which is slightly different to what we're used to on the minimum standards. But that table could potentially lead to copy and paste scenario into specs, because it's easy to potentially do that if you're not understanding the document and the methodology behind it. And also the values published within that table are not necessarily, well, they're certainly not correct in regards to the thermal conductivity at the temperatures you'd expect. And also the two instruments that are listed do perform differently to one another. However, there is a clear calculation methodology within the document, which if followed correctly by the consultant, it can form the basis of a compliant sort of installation specification for CP1 or a schedule, which in turn makes it easier for the contractor to understand what they're pricing and installing, obviously at a later date as well.
Excellent, thanks. So some potential wins and advantages, but also, as you've described there, potentially some complexities and considerations as well. So coming to you, Michael. So the CP1 2020, is it really the catalyst for major industry development? What I'm kind of asking you, should we believe the hype? So is it that major catalyst? And if so, what are the key changes then?
Hi everyone, my name's Mike Ridge, Principal Engineer at Fairheat. I was on the steering committee for CP1, so quite heavily involved in changing 2015 to where we've got to with the 2020 version. And I work for a company called Fairheat, where we do essentially quality assurance of heat networks. So CP1 is used on a daily basis by me and my engineers. I think, to answer your question around, is it the catalyst for major industry development? I think it can be, yes. I mean, if we want major industry development, we need investment. We've got a lot of public investment already in heat networks, and that's actually growing. There's going to be a massive public investment through things like HNDU, HNIP, the Green Heat Network Fund, and they all specify CP1 2020 as a mandatory requirement. I think what it can do in the private sector is provide investors with a lot more confidence than they have previously had, because the document is fundamentally outcome focused. So it defines what the outcomes of the heat network need to be in terms of heat losses that Stephen was alluding to, network performance, efficiencies, cost of heat. And when an investor can see those outcomes defined, they can build confidence in, if this is specified and followed, I can build a business model that says, okay, this is what I'm going to get at the end. So in terms of that catalyst, I think it can be yes. And it provides good transparency to investors in heat networks of what they will end up looking like. We're seeing a lot of build to rent market in the UK, and that often means that the people who own the building in the end are not necessarily the ones that necessarily built it in the first place. And so those building owner operators being able to specify something like CP1 gives them some influence and control of the product they end up getting. And that, to be honest, the same can be said for Section 106 purchases in the housing association world. They have quite limited influence over the spec, and so naming something like CP1 can give them great confidence. In terms of key changes, that the compliance checklist that Stephen mentioned, I think is one of the major ones, giving a framework of how do I take it from stage 1 conception all the way through to build. That process for a heat network build changes hands multiple times. So that compliance checklist is really key for staying on top of that. And then I'm sure we can dive into the details later, but we've got improvements on hot water delivery times for residents, which have been a problem in the past. We've got an increased testing regime, things like acceptance testing of dwellings and plant rooms to make sure that prior to handover, the systems actually work. And then the installation one is a big one that Stephen was talking about. For me, what Stephen is talking about in terms of the methodology, the loss target of 100 watts a dwelling, hitting that, fundamentally, if we can get all the heat networks with losses of less than 100 watts a dwelling, we're a long way down the road of them being very, very useful infrastructures for decarbonisation, and we'll get good resident outcomes.
Excellent. And if I could just drill down into the detail a little bit. So Michael, when it comes to pipe thickness, sizing, materials, what does the code really say about those kinds of specifics?
Okay, so on pipe sizing is a big area in CP1 that's developed significantly since the previous version. To size pipes, you have to know what the loads are, and to do that, you have to know what diversity to apply to hot water and space heating. In the previous code, we had multiple different diversity curves. Now we've got one. And so the industry can converge on a sensible approach to determine what the loads for the pipes are. There's also been a development in pipe sizing, moving to a velocity-based approach for dwelling level pipe work, which will enable smaller pipes. And what that means is for a given dwelling load and building load, we can do it with smaller pipes. So we can get more insulation on that pipe for the same corridor space. So we're bringing pipe sizes down. There's a really clear methodology to follow in the document to do that, which means for a given footprint of a pipe, we can get more insulation and lower losses. That should help with coordination and losses hand in hand, really.
Great. That kind of clarity is definitely an advantage. And Chris, welcome back just in time for my first question to you there. So I wonder if I could ask you to do a little myth busting for us, please. So what are the most common misconceptions regarding heat networks amongst thermal contractors? Bust those myths, please.
Okay, yeah, well, first of all, thanks for inviting me. My name's Chris Ridge. I'm Technical Policy Manager for TICA, who are the Thermal Insulation Contractors Association. So we have about 80 odd thermal insulation contractors who are members of our association. And I think the first thing, when we look at the myth-busting element of it, I think actually there's still a degree of ignorance in the market, I think, about heat networks full stop. So I think the first thing is that we haven't even got to a position where we can even sort of look at many of the myths to bust, if you see what I mean. So but I think the ones who are aware of it, and by the way, what we're doing as an association is to raise awareness of heat networks and what the CP1 Code of Practice says and what it means for our members. But when we look at it, I think the first thing is that people naturally just go to the area of most information for them. And for the thermal contractors, they see a thickness table of insulation of 50 mil insulation, whether it's mineral fiber or whether it's phenolic. And the easiest, if you like, the route of least resistance in that case is probably going mineral fiber, because it's a cheaper product per if you like, per millimeter of thickness. But actually what they're not being aware of then is the thermal performance criteria, and I think that's the first myth we have to bust with that, is that actually it's not just good enough to pick your thickness of insulation and go with it. There's a lot more detail in this. There's a lot more early design element in this. And I think the second myth, really, which is probably one we've seen before in other circumstances as well, is I think the feeling in the industry that it's just another thing and it'll go away and it'll be something different next week. This is a trajectory that we're now following that is really, really important. And I think what we're going to see is we're going to see more quality assurance built around thermal insulation of pipe work and the application of the code of practice. And I think one of the reasons why thermal contractors are maybe not seeing this already is because, if you like, the people holding their purse strings are the M&E contractors, and I think there's an awareness job to be done with them as well, you see. So I think actually this needs to go all the way through that contractual route. So and I think if we do that, actually what it'll mean for the thermal insulation industry is that people will recognise the importance of good thermal insulation, contracting, good install, and so it's important that we sort of bust those myths and actually move to a better place.
Excellent. And could I just ask you there then, so if there is that maybe a combination you suggested of ignorance or reluctance or just a sort of lethargy, is that resulting in an opportunity cost? Is the industry actually missing out on business and wins by not really picking up the baton and running with it?
So, sorry, is that to myself again?
Yeah, sorry, yes, follow up to you.
So absolutely so. I think dare I say, the potential issue with the thermal insulation industry is that it's just not valued by the wider construction industry enough. And I think, I think the point is that when it's undervalued, it almost becomes surplus to requirements. I think actually what what's happened, and CP1 is a representation of this, is people are beginning to realise just how important thermal insulation is to the overall carbon reduction message. So actually, yeah, this is a really key thing, and mechanical electrical contractors engaging with good thermal insulation contractors early is going to be really important, and it's going to be really, really positive for the industry. Excellent, positive note. And now, if Mohammed, I could come to you. So from an energy perspective, I wonder if I could ask you, what role will heat networks play in net zero 2050? And follow that, why will insulation standards matter, please?
Hi, I'm Mohammed Sharif. I'm the design manager at E.ON UK. Well, I think what heat networks play as a role in achieving net zero. I mean, like, the debate has been going on, and a lot of great minds have answered that. But I'll give you an E.ON perspective of what we think. Again, we think the heat networks play a very vital role in our drive to net zero. I mean, in short, it's like we need to be kind of generating 100% renewable electricity and electrify heat. Now, electrifying heat doesn't just really mean putting in source heat pump and ground source heat pump. What we are doing at E.ON is kind of looking to use low-grade heat, waste heat sources, which cannot be utilized in individual houses, and that could only be scaled at a heat networks level. Right. Now, when we're talking about low-grade heat sources, the stuff that we're looking at, I mean, it's astonishing. We don't even think about that. I mean, there are data centers that are emitting megawatts of heat. There are sewage treatment plants, there are TFL tube stations, interconnectors. I mean, there are megawatts of heat coming out from all of these sources. So all of these sources cannot be put into individual houses. They have to be put into heat networks. And by utilizing that waste heat into heat networks, that is, and electrifying by using heat pumps, that is our strategy for going forward to kind of achieve the net zero drive, and that's where we see heat networks spanning out. How heat losses can help on our current, I mean, like at the moment, E.ON operate over 60 heat networks across UK. We do see a wide range of heat losses on them, ranging. Some of them we've built ourselves, some of them we've adopted, and it kind of ranges now. So E.ON, again, have their own specifications, which are in line with CP1 on the insulation thicknesses. We do see the difference between, and we can compare from our sites what a standard British standards insulation thickness gives a heat losses at, and what a thicker insulation, say E.ON standard or CP1 compliant insulation would give. And the results are astonishing. There is at least 30% difference in heat losses that we would see. So in the future, we're talking about kind of generating low carbon heat, but if we're losing 50-60% of that in losses, that doesn't make sense. The drive for net zero will be longer and longer. So we should be kind of looking to improve the insulations, which we're glad as an ESCO who are running the heat networks, very happy that something of CP1 has been put forward, and it's kind of hasn't been mandated yet, but it's kind of put onto radars of developers, and they're kind of specifying this as something that their sites would need to be compliant with. So I think it's in benefit for everyone.
Excellent, thanks. And nice points there about in terms of electrification and low-grade heat. Really a call for more systemic thinking if we're wanting to talk about scale. It's not a house-by-house type response. And I think to illustrate that, am I right in saying, I think you said you had something like 60 networks at E.ON. Haven't you got something like 35,000 customers on that or something? Some numbers. So that gives you an idea of those kinds of numbers, and that's potentially the sort of scale we're talking about. So thank you. And I've now got another little round of questions, and I'd remind the audience to pop their questions in the Ask a Question button, probably at the bottom of your screen if you've joined us late. So, but now I'm going to a little deep dive now. I'd like to quiz the panel a little bit further about the challenges and opportunities. So, Chris, I'm starting with you this round. So we hear a lot about the importance of retrofit for our climate goals. So what does the thermal insulation industry have to offer from that perspective going forward?
Okay, well, obviously a lot. I think first of all, it's worthwhile emphasising how important retrofit is going to be in terms of reaching our net zero goals. So I think this is probably a much commented on the thing of recent, but 80% of the buildings that we will have in 2050 are already built. So whilst we need to obviously look at the best possible design for the 20% that we're going to build, then that 80% is massively important. And I think, you know, there's some good work going on, you know, in terms of both operational and embodied carbon with retrofitting buildings. But I think a lot of it, from my point of view, it seems that there's been a lot of talk about low-hanging fruit. I've heard that a lot recently. It's a phrase that is always bandied around, but it's been used even more so of recent. And yet, insulation, pipe insulation, thermal insulation is rarely. I think it's such a low-hanging fruit. It's below our eye line. We're not even seeing it. We're looking, I don't know, we're looking at solar panels or something like that. We're not actually seeing some of the stuff that should be right in front of us. So I think obviously the important thing is that it's good thermal insulation is included in the designs for all the retrofit work that needs to happen. And I think, you know, even drilling down further than that, there's even small, medium companies are going to come under increasing pressure to have their own net zero targets met. People are going to have to effectively lay out their own net zero carbon reduction plan and report on how they're going to meet them. And in the construction market, that's going to be really important, because obviously it won't just be the main contractors that need to do that. That's going to have to be policed down the track. So what can they do? Well, again, that low-hanging fruit, one of the easiest things to do, and we could get into a conversation about the efficacy of heat pumps versus how quickly hydrogen's going to be on the market and things like that. But whilst we're waiting for the market to catch up with all of this, then people can start by just insulating their pipework, and maybe little things that add up, like insulating valves. I mean, there's basically if study that I can actually post on here later on shows that you take all the industrial thermal pipe insulation that is inadequately, or the pipework that is currently inadequately insulated, you add all that up, and that's just on the industrial side. That equates to the energy consumption. I think it's 863,000 houses. So there's a huge amount of stuff that can just be done about better insulation of pipework. And we know structural insulation gets a real, you know, that's in the news constantly at the moment. So let's look at the other stuff, definitely.
Excellent. Yeah, well, nice point there about all those incremental improvements can collectively add up to an exponential shift in terms of where we are. And a call, if I'm hearing you right, basically start now. Even if you start small, start now. Don't delay. So Mohammed, if I could come to you then. So at the sharp end, when it comes to winning business, what might the potential impact and influence of the code be on the procurement of heat networks and literally on tenders?
Having looked at the and fed into the code of practice myself, I'm very pro for it. It will result in having better performing networks. We would be this will ensure in procurement of heat networks that are efficient. It sets minimum standards that someone should be following in terms of designing and operating of these networks. As speaking from an ESCO's point of view, we would fully support that, because it's in our interest that any network should be performing as it is designed, and it should be designed correctly as well. And because as CP1 gives the current guidance on how they should be designed and how they should be operating, I think this definitely kind of pushes the procurement of heat networks which are more efficient, better performing, and it's better for kind of everyone in the industry, I would say.
Excellent. And yeah, so it could prove a differentiator for sure. And and Michael, so if I were to come to you, Mike, can you explain for us, please, the actual benefits of using CP1 in the early design process, and bottom line, truly understanding the cost implications. So early design, cost implications. Can you spell out some of the benefits for us, please, Mike?
Yeah, sure. I mean, early design, if you progress the design and then you try to make changes later on in the design process once decisions are made, those design changes become a lot more costly to implement. So starting off making design decisions as early as possible in line with CP1 are going to be the most cost-effective way at getting those new minimum standards in place. It also gives the client cost certainty and foresight around, if we're defining the outcomes at the start, building a design around that. Even at stage 1 and stage 2, I can start to build a cost model of what this heat network is going to look like with confidence. If I'm leaving that till later on in the design and making changes, that starts to put a lot of uncertainty on the budget, but those changes are going to be, as I said, quite costly to implement. There's things about CP1 that if you leave too late in the design are simply not possible to implement. So one of the major changes and one of the big pushes of CP1 is to reduce network length through moving away from a single riser corridor routed approach to multi-risers, and potentially even moving the HIUs, so the heat interface units that normally go in a flat externally. And that can strip out 75% of your network length. I don't think that's often realized, that the size of the prize there. If you leave that to REBA 4, when the architectural design of the building is complete, you can't make that change. And I've had this fight quite a few times at REBA 3, REBA 4. It's very, very hard. If you do it at REBA 1 and 2, that's when you can get it in. So early implementation is key to maximizing benefits. In terms of the cost, I think there's, going back to that myth conversation, I think cost there's some misconceptions around cost. I think maybe the standard might be seen as gold-plated standard that's going to increase capex to get these life cycle benefits. There are a lot of life cycle benefits, and the whole model of the standard is to reduce life cycle costs. But there's actually a lot of things that reduce capex as well. So the new sizing approach will bring the size of systems down. So we'll be purchasing less kilowatt plant of generation. The pipe sizes are coming down, so we'll be installing, a smaller volume of pipe work, so that those costs will come down as well. There is a cost associated with implementing CP1 on a quality assurance, level, and getting independent party to sign off at each stage, but that cost is negligible compared to the benefits of reducing size, reducing pipe work. I mean, capex alone on system sizing, we've seen, £1,000 to £2,000 a dwelling capex reductions be possible through using a CP1 sizing approach compared to using some of the old diversity curves. So I really want people to understand it's not a gold-plated standard that makes capex more expensive to get life cycle cost benefits. There's a lot of stuff in there that will make if you procure a CP1 in full, your heat network will be less expensive than what your previous benchmarks were. I'm pretty confident about that.
Excellent, thank you. Nice on call for early implementation, and a good point there on not misunderstanding the cost implications in terms of capex, for example. So finally in this round, before we go to the audience, I already see a couple of questions popping in there, so do type them in the bottom. So Stephen, you're last before the audience Q&A. So one of the big questions, of course, is what needs to be done in terms of industry upskilling to ensure that heat network installation specifications are understood, but also that contracts actually get awarded on the basis of compliance. So upskilling, Stephen.
Okay, I think, so industry bodies, associations can help informing the industry of the changes. Running seminars and events like this one today can certainly help. We do hear sort of many examples of projects where it's been priced to CP1. However, the contractors are then asking the thermal installers to let's price it in BS 5422 thicknesses, and we'll submit that and see how we go, which can be a bit of a pointless exercise in some ways for those tendering contractors, because if it leads to installing those non-compliant thicknesses, that can lead to increased costs when having to go back and correct that install and uplift to compliant thicknesses. So but also from a manufacturer's point of view ourselves, we're actively engaging with the industry to advise on the changes and how it can affect them. And we do offer that free technical assistance in way of heat loss calculations and a CIBSE approved CPD on the topic. Now, that's not just to consultants. We want to engage more with M&E contractors, whereas, like Chris mentioned earlier, where it's a little bit that part in the chain is where the understanding of the change in CP1 maybe isn't quite there yet. So I think it's not just speaking with consultants; it's the whole chain really in terms of involved with projects.
Excellent, thank you. So that takes us then through nicely to the live Q&A. So this is where the panel have their fingers on buzzers and they're sitting upright in their seats in anticipation. So keep the questions coming. They're from Mohammed, Michael, Chris and Stephen. Pop them in the box at the bottom. So first off, I think there's one actually in the chat I'd like to pick up first. And I think perhaps for you, Michael, because you did discuss some of this, it's a straight question from Fresh Kuali, who asks, who is qualified to undertake the new calculation for insulation thicknesses? So who's qualified to do that job?
I don't think there's a necessarily one qualification. I mean, you can get you can become a CP1 consultant. So there's a training course and then an exam to become a CP1 consultant. But it's typically going to be, building services, M&E consultants that are working doing the building design. They might outsource that to some of their thermal contractors, but it's typically going to be done by the M&E consultant who's doing the whole design. They've done the network routing. Then they're looking at basically pipework lengths, pipework sizes, and then putting in different thicknesses of watts per meter for the temperatures. And the goal that we need to get to, going back to the points that were made earlier between Stephen and Chris on this whole minimum 50 mil phenolic and rock wool, mineral wool, you've got to get less than 100 watts a dwelling. And you can do different thicknesses. So you go higher than 50 mil or lower where you have to in terms of that drop down to the HRU. You're probably not going to get 50 mil on that every time. You need to do a calculation to prove that you're hitting that key performance metric, because that's the outcome that we want residents and network operators to have, is less than 100 watts a dwelling. And that's the key. Get less than that and then be flexible in your design around, do we upgrade some of the insulation on a riser because we have to drop down on terminal runs and those sort of things. But 100 watts a dwelling is the key outcome that consultants need to be calculating and demonstrating. And the key is it's going to be tested at the end. So it needs to follow through the install as well.
Good point. And then Chris, hand up.
Yeah, I mean, I'll just add to that and probably throw Stephen into the mix with this as well, quite nicely. But I think the important thing that Michael is, or one of the important things that Michael is picking up on there, is that it is early engagement, but this actually imposes upon manufacturers as well a degree of responsibility. And if a manufacturer can be given a certain base criteria, such as the temperature of the pipe work, the size of the piping, then that they should actually be able to stand behind their product and say, well, the thermal losses with our product to this thickness will be this watts per meter or whatever it is. And they need to build that into the equation early. If they can do that, and then if thermal contractors can also follow up on that and ensure that they have that information, then we should find this all starts to line in with the whole kind of principles of golden thread that we're trying to work to as well, I think. So I think that's just a key thing to put in there. And I'm sure. Yeah.
Oh, no, it's not.
Flashing the baton, yeah.
No. It's I mean, whilst we can't do the watts per dwelling heat loss calculation, and obviously that wouldn't be for us to provide that, but we can provide the watts per meter heat losses of the insulation, and depending on which insulation material you're going through on the project, whether it's Kingspan phenolic or others, it's key to check the performance data, the thermal conductivities at the temperatures that you're working to. So then ourselves and I'm sure others can then provide the watts per meter heat loss figures for each pipe size and so forth, and the insulation thicknesses, which then you can use that to work on your watts per dwelling calculation.
Excellent, thank you.
Would you also say, Stephen, that manufacturers and installation contractors could provide and need to provide information around, the ratings of valve boxes, termination points, handles, those sort of things, where you're not necessarily going to have a watts per meter, but if you can help the consultant say, I've got this number of valves, so this had this total watts, then they can build that into the calculation as well.
Yeah, that's how often we see, obviously, the valve jackets and other parts of the system is usually insulated with other types of products that don't have the same performance as the rest of the system. So like you said, Michael, yes, it's definitely key to consider those elements as well, and where potentially you could look at other solutions, for ourselves as well.
Excellent. And taking a question, we have one from Gaizam Karaman asking, thinking of the life limitations of materials, are specified insulation materials recyclable, sustainable? Can we encourage more environmentally friendly materials in heat networks? Before I perhaps obviously throw that to Stephen and Chris, could I bring Mohammed in on that question first in terms of sustainability, materials, obviously wearing your E.ON hat, but also as a code contributor? I wondered if you'd just like to offer a perspective on thinking maybe more about sustainability in the round in that sense as well.
Yeah, I mean, we do specify, again, it's something we've developed our own standards on what should be contributing it towards a heat network. Again, we are not able to mandate that, but it's a good practice guide. We always kind of specify something that is more kind of recyclable and more sustainable to be used on sites. And it comes down to, again, I mean, it's again not more of a residential, but we're using these ones. People do get BREEAM ratings, good BREEAM ratings on non-domestic ones when they do use. So that it's a driver in the non-domestic one, but residential still needs to pick up. But yes, when the Code of Sustainable Homes was around, that did recognize and allocated credits on that basis. But now it's not there at the moment, but it's kind of, again, it's a good practice that people should be kind of focusing towards that.
Excellent. And Stephen, then, if I could bring you in on that, obviously Kingspan been strong contributors to the sustainability narrative for a good number of years now. But what's your response then to the question in terms of materials, recyclability, sustainability, environmentally friendly? What's your first thoughts on that, please?
So, of course, if you were to be using our products, you need less insulation than competitors' products. Also, we've recently achieved from the BRE the Environmental Product Declaration certification for cool firm pipe insulation. So that's in regards to the embodied carbon side of things and production of the material. So if you've got people interested, sustainability consultants in that, then you can download that from our website. I'm sure we could probably put a link in the chat as well. But on top of that, Kingspan have got a Planet Passionate scheme, which is a number of different initiatives in terms of renewable energy sources, being self-sufficient in all our manufacturing facilities. So it is very key to Kingspan right across the group, not just installation, the whole group. So, and again, if you wanted to find out more about that, then there's all the initiatives, because there's a long list of them, which if I were to list them all off, certainly we do have a Kingspan Passionate website, which Planet Passionate website, which you can see all the initiatives that we're undertaking now.
Excellent, thanks. And Chris, then, if I take it to you, maybe more widely amongst members and things, obviously they're wrestling perhaps with CP1 and what it entails. They're also wrestling with sustainability agendas. Does it help them to do the two together, or is there any danger of conflict there in terms of them trying to address some of these things?
So, well, I think the one thing that we, if you like, our members are probably just starting to wrestle with is the understanding of the difference between operational and embodied carbon. And I think it's still early days for Kingspan, as you'd expect, are one of the first to the market with their environmental declarations. A few of our other associate members who are manufacturers have done that, but it's still quite early days, and I think it's there's some work to do with that. And I think looking from the installer's point of view, we just need to encourage manufacturers to do their bit with this now, and help our members to understand what it means.
Excellent, thanks. And Mike, if I came to you last on this question, then in terms of materials, I wonder if you could say a little bit about sustainability. How much innovation is there in the market, or is it simply more a matter of just scaling what we've already got?
At the moment, within the heat network sector, the sustainability focus is very much on reducing carbon emissions of the operational system. So, removing gas CHP, bringing in heat pumps, making them as efficient as possible, reducing heat losses, and insulation obviously play a fundamental part in that in terms of how much insulation we can get on the pipe, etc. I think this whole push about embodied carbon is fairly new, or it's been brewing for a while. And it's becoming much more on people's minds. It's becoming on developers' minds. They're pushing their own agendas, and also there's some local authority requirements being met within the GLA, and that will go countrywide. That for me is going to promote conversations around the embodied carbon of the materials and equipment that we use, and then that's going to get conversations going around the differences between the products, not just from their thermal insulative performance, but their raw embodied carbon. That's going to push innovation. Manufacturers are going to want to reduce their embodied carbon. So I think we're at quite an early part of that journey. Performance-wise, heat networks-wise, we're a longer way down that curve. But I think the key is we're talking about embodied carbon, and that's going to promote these conversations and promote innovation in these areas to push that footprint down as well. Excellent, thank you. And audience, do pop your questions in the bottom. I have another one actually for you, Mohammed. If I could just ask you a little, having mentioned that you're a contributor to the code. I mean, there's a sense always with these long-awaited pieces of regulation or guidance or standards, 5 years in the making, as it seems to some. Yeah. It's always the big day when the code is out, but that's one thing. There's then a whole communication piece after that in terms of how the industry responds and uses it and the speed with which they respond. So as a contributor, perhaps personally, I'm wondering if I could ask you to comment on, do you feel the conversation, the feedback, the response is what you might have expected? Are you pleased with how the code appears to be getting picked up and used, or are you disappointed that perhaps it's not being tackled as quickly or as earnestly as you might have hoped? What's your personal feeling on the feedback so far?
I'm very positive about this because when the code is out and the communication has been brilliant on it, on the CIBSE website, and how CIBSE has gone about and kind of done different CPDs and the roadshows to kind of to kind of educate the market that the CP1 has been out. We do see a lot of developers specifying CP1 as a mandate. Some of them do not understand what is actually required, but they want to do it. They're up for it. So that's a good thing. So it's people are aware of something that is in the industry and that they have to be following it. But there's a bit more piece of education that needs to happen of what the CP1 actually entails, and it's again down to individual to kind of educate themselves. And we again, when we deal with developers, contractors, and manufacturers, we educate them on what the CP1 entails and their responsibilities, because it starts right from the developer's responsibilities and right up to someone who's kind of operating it. Everyone involved in the whole life cycle of that have got a part to play in implementing CP1 on the project. So yeah, everyone has to educate themselves, and wherever possible, we do that on our, it's again in our interest to do that.
Excellent. And Chris, perhaps if I come to you, I've got a little question coming via Twitter. It's really addressing the old idea of insulation as the Cinderella subject. It's a cliche, but the energy ball. Is that still a myth? Is that alive and kicking? Is it still I mean, you talked about it being perhaps taken for granted or so obvious that people weren't necessarily appreciating what they could do and the change it could help. So is there still some of that? And if so, what can we be doing to change that perception?
Right. Yeah. I mean, definitely it feels true to me that hence earlier talking about the fact that it's the low-hanging fruit that is so low, people aren't even seeing it in their eye line. What we do about it, I think Michael touched on this earlier, but an increase or an improvement in quality assurance around insulation and ensuring that meets the specification requirements. Actually, it puts insulation further to the top of the agenda, and that's really important, because effectively it's been taken for granted for so many years, to the point I think people are almost looking at putting out their subcontract for thermal insulation just as a either as a means of getting it done cheaper than they could with their own heating and plumbing engineers for a start, or secondly to just offset the responsibility and pass it on. This is all wrong, because actually it's a really important trade. It's a very skilled trade. We need more apprentices coming into the trade, just like everybody else, by the way. But it's a fantastic trade to be part of, and I think the more now, obviously my role is to try and raise it above that, up that agenda as much as I can. Everything we can do to encourage early engagement with thermal contractors, everything we can do to increase quality assurance and work with the other stakeholders like Fair Heat, for example, and E.ON to encourage that. This is only good, because the good thermal, it's a game theory situation, isn't it? That the good thermal contractors are currently getting underpriced by people who are maybe not reading the specs correctly or swapping materials around and things like that. What's good for the insulation industry is that the good thermal installers get recognised for what they do, and we can all make it happen.
Excellent. That recognise and reward, and it's a team game. And I could see you nodding there, Mike. I don't know if you'd like to add a little about how we get it more front and centre, and also enable organisations to really reap the benefits. This isn't a nice to have; it's essential and it's beneficial.
Yeah, I mean the insulation, the standard of the install of the insulation, once you've designed a heat network and everything else is fixed, is the single most important factor of what your heat losses will be, and then fundamentally how your carbon intensity of heat, but also cost of heat to residents. So, I mean, Chris's comment around it being a skilled industry is a really important one, in terms of there are skills specific to contractors in terms of how do you insulate and box up a complex geometry of pipe work and make sure that we're not having gaps there. Like, that kind of skill, I think, is sometimes underappreciated. And from a quality assurance provider, I can't inspect every inch of pipe. So part of my role is getting upskilling, educating, and actually building a feeling of pride by the install contractors in this is the impact my work is having on fuel poverty. This resident living in this home, if I do this right, this person is going to be spending less on their bills, and they can spend that on things that other things that they need. And so I've seen a big impact of that kind of engagement of a quality assurance provider in getting people to be proud about their work, understanding the impacts of what they're doing on a day-to-day basis. And that's something that we shouldn't overlook. Excellent.
Pride in their work. And I have one more round of questions, but I'm sure, Stephen, you might want to comment there on insulation and raising it up the agenda. Obviously, you're keen to talk about insulation, goes without saying. But do you feel CP1 will help move those conversations up the agenda? Are you confident that you're going to be talking to more people more about better things?
Yeah, no, for sure. I mean, obviously, since the standard came out, the start of this year, we've had a lot of engagements with consultants, and certainly since we launched CPD. But yeah, no, I think it's, trying to see moving forward is see more detailed specifications, like I said, to help those thermal installers, so they have a clear instruction of what they need to do. I think the consultants are very good at producing the calculations, but as we mentioned before, sometimes installation can be a little bit of an afterthought, certainly when it comes to specifications, and we do see a lot of outdated specifications, and the contractors certainly do, where it can contradict itself. So I think, I understand consultants have a lot to do on over the whole project, but to produce a more sort of concise and detailed specification in relation to CP1 will certainly help the contractors understand what they need to do so they can get it right first time.
Excellent. Nice point made. And so then we're into the last 10 minutes, almost 9, the clock's ticking. So I have one final round where necessarily we've talked about some of the challenges, the difficulties, whether it's an implementation or understanding. So we've been talking about the tricky stuff, but I'd like to finish with a bit of future gazing of a very positive kind. So we're moving to a close. We're going to get out the crystal ball. Reasons to be cheerful. I want you to, all 4 of you, please, to put on your rose-tinted specs and share some really positive visions about the art of the possible, where we could go in a CP1 world if some of the good solutions and positive measures you've been talking about are put in place and enacted. So fast forward 5 or 10 years, that's all, just 5 or 10 years. What does success look like for heat networks, insulation and cutting carbon. So Mohammed, if you'd like to start us, give us a vision of what success looks like in 5 or 10 years time if we've really picked up the baton and run with this successfully.
I think we've been kind of heavily trying to implement this, and what we do foresee is in short a better performing network. The heat heat losses reduced, and people kind of trying to again in the UK industry, I would say the heat network is still very young. And it's starting to grow now, and people are skeptical on connecting when they're being they're told that they have to connect to a heat network. The reluctance is there. So with this in place, I see people getting more confident in kind of and engaging to kind of connect to a low carbon heat network. And it will be the, again, as the industry changes in 5-10 year time, I mean, like there'll probably be something new. I mean, like hydrogen would probably be kind of into the market a bit more, but we will definitely see heat networks expanding and heat networks performing much better. That would definitely, I'm hoping that would definitely kind of help the residents in kind of having a low tariffs. Again, ESCO's kind of making profit on that, which could be shared with the residents. So yeah, it's in a nutshell, better performing and more heat networks is what I would say.
Great, yeah, a real win-win scenario, better performance, more market confidence. Mike, if I could come to you, sell us your uplifting vision of where we could be going in 5 or 10 years time if we really do the right things well together.
Yeah, so for me, in 5 years time, we'll be seeing far more networks operating at 60-30 temperatures compared to what we've seen in the past, 70-80 degrees. We'll be delivering those 100 watts of dwelling. That's what we need. At the moment, we've probably got 300-400 watts of dwelling on average, and we're going to, in 5 years time, we'll have had a whole generation of heat networks through good insulation and good design, getting that 100 watts of dwelling. And that means our cost of heat will be coming down to residents. I think we're going to see a big increase in investment from the private sector once they realise that heat networks can be an attractive vehicle for investment for them. Zoning is going to be massive, where we've got zoning policy consultation out. That promoting more heat networks is key, and I think we'll see the benefits of that in 5 to 10 years. We need to connect more public sector buildings to heat networks. There's a big focus on the busy sector, but we've got a big contribution to make to public sector decarbonisation. And really key one is we need to see the air source heat pumps and the ground source heat pumps deliver their promised seasonal coefficient of performance that they're all going through energy strategy and design right now. They need to be actually delivering those COPs, or we've got a big problem. And Mohammed's point earlier, we will have hopefully start to hit a scale where the smaller networks get interconnected and we can start tapping into proper waste heat sources. And that's where we really start to get the benefit of heat networks giving carbon reduction benefits.
Excellent. And so 100 watts of dwelling, cost down, investment up, zoning, and throwing down the gauntlet a little there for heat pumps. So it's the last 5 minutes. So Chris, 5-10 years ahead, paint us that rosy picture.
Yeah, well, I think we've got to remember what we're working towards with this, and it's a net zero 2050 ambition. I think what success looks like is that yeah, well, we get there in 2050, but that we can see by the end of the decade that we've made those significant strides already. And I think what is evident is that to get to that point and to see that by 2030 we're making that progress, is that heat networks are going to have to do a lot of the heavy lifting with this. So I think that's really important. I think what success looks like is also important for our industry, because success means a well-respected thermal insulation contracting industry, and thermal contractors being recognised for actually being part of the solution for something that is really, really important for all of us.
Excellent, thank you. So progress down the road towards net zero, and hopefully we'd have some interim targets as well to help focus the mind more as we go along. So then last word to you then, Stephen. So 5 or 10 years time, give us that vision before we close. What are we seeing?
Well, having to go last, everyone's stolen all my answers. But no. I mean, to remain positive, I mean, at the moment, I mean, there's a significant investment from the government, so hopefully that continues over the years, which you would like to think it will. And obviously, it'd be good to see if the targets are met that they've set. So at the moment, I think it's roughly 2% of the heating needs is only met through heat networks. Yeah. And the target is to reach 10% by 2030. So that's a good, obviously, like you said, 5-10 years. So hopefully they can hit that target and we see the growth in the networks. But also, we've touched on, obviously, CP1 has raised those levels of insulation. So when we compare it to the previous document and sort of older projects. So as this is implemented over the next 5 years, it's good to see, we'll see the reduction in losses on the network, which in turn can help reduce the operational carbon, which then, as we've been saying throughout this past sort of hour, is helps towards that net zero journey to net zero, helps us achieve that as well.
Excellent, nice point to close on. And yeah, as we all realise, 5 or 10 years actually means those 2030 targets happen within that time frame. So it's later than we think, and there's still a lot to do. So thank you very much. So in closing, then, we are bang on time. A big thank you to all our panelists, Mohammed, Michael, Chris, of course, Stephen, and our sponsors at Kingspan. To yourselves, our virtual audience out there, for the comments in the chat and questions. A reminder to check out elementalexpo.com, which I said at the top of the show is online community for professionals focused on innovation in heat, water, air, and energy, the vital elements within the built environment now and in the future. Find a full diary of events on the website, upcoming webinars. This will be available almost immediately afterwards to watch on demand and to share. And I hasten to add, it is all free to access. So thank you once again to all the panel. Great job today. That's it for now. I've been Jim McClelland, editor at SUSMEME. Thanks for watching, and we'll see you all again soon. Thank you very much.
Thank you.
Thank you.
Thank you.